Hey guys, this is Miss Avellan. Today we're going to be talking about valence electrons. Valence electrons are the ones in the outermost shell of an atom. So here we can see an atom of lithium, and the outermost shell, the one that is on the last surrounding the atom, is going to hold the valence electron, or the lonely last electron over here. Families and valence electrons have a lot in common. Let's examine the first family, the alkaline, and we will do Bohr models for each element that is a member of that family. Remember that the alkaline, the first family, is the one that we're going to find at the beginning in the periodic table. Here we can find them right here. Let's do Bohr models for each element that is a member of this family. Remember that it doesn't start with hydrogen because hydrogen is a non-metal, and these are all the alkaline metals. So we're going to start first with lithium, then with sodium, then with potassium, then with rubidium. Finally, we're going to cover cesium. Do you find anything at all in common between the valence electrons of this alkaline family? Yes, you are right. The valence electrons, the outermost electrons in this family, all of them have only one valence electron in this family. And that's going to be repeated for all of the families of the periodic table. So the valence electrons will be the first to be lost by an atom, because the outer shell is the one that is most in contact with other atoms. Can you guess how many valence electrons are in each one of these atoms? Here we have carbon that has 4, oxygen that will have 6, you can count them right here in the last shell, and in the last shell here, beryllium will have 2. The valence electrons will be the same for all of the members of a family in the periodic table. We see the periodic table right here. We're going to notice that this first family, excluding hydrogen, the alkaline, is going to have 1 valence electrons. The alkaline earth will have 2 valence electrons. Let's skip for now the transition elements, but we're going to go back to them later. The boron family will have 3 valence electrons. The carbon family will have 4 valence electrons. Nitrogen family will have 5 valence electrons, and the oxygen family will have 6. Halogens will have 7, and the noble gases will have 8, and will have a complete outer shell. Here's a way for you to memorize it very easily. Notice that back here, helium has 2 electrons, so it will not have the same as the rest of the family because it has only 2 electrons. So in that case, helium is only going to be right here, the only member of the noble gas family that doesn't have 8 valence electrons because it only has 2 electrons. So we can determine the number of valence electrons by using the periodic table. But there is something to be said about the elements in group 3 to 12, the transition elements, because they do not have a general rule. However, we do need to memorize that they typically have between 1, 2, or 3 valence electrons. So when you have to determine the number of valence electrons that they have, you can say either 1, 2, or 3. We draw Lewis dot structures to represent the valence electrons of each atom. What we do is we start with the symbol of the element, in this case magnesium, or in this case aluminum, and then we determine how many valence electrons there are and draw in the number of valence electrons as little dots. Here's an example for nitrogen. Notice that I am putting the electrons on opposite sides because they repel each other, and that when I have to add a third one, I will not put it next to the first one or the second one, but on the other side. If I had to add a number 5, like in nitrogen, then I'll put it wherever it is near. And also notice that I am putting them in specific places, not all around the atom, but in specific places. You can easily tell the number of valence electrons from a Lewis dot structure. Now, the octet rule is a rule that says that atoms prefer to have 8 electrons in their outermost shell, or 8 valence electrons. Why? Well, because they'll be more stable if they do. Consider, for example, sodium. If sodium was to lose this valence electron, if he has these 8 electrons in his last shell, he will be very stable. So he would rather lose this 1 electron than have it in there and not be stable. In general, the octet rule that says that atoms with less than 4 electrons tend to lose the electrons. The family is from alkali to carbon. So let's look in the periodic table, the family is from alkali to carbon. This one will lose the 1 electron that they have, because they will be more stable. This one will lose the 2 electrons that they have because they will be more stable. The same will happen to the boron family. When we get to carbon, carbon has to lose 4 or to gain 4 in order to achieve 8. Now, atoms with more than 4 electrons will tend to gain them from carbon to halogens. So we can check out in here families from carbon to halogens. The carbon would rather gain or lose, will be the same for carbon, but for nitrogen that he has 5, he would rather gain other 3. For oxygen that he has 6, he would rather gain other 2 to have 8. And for the halogens, they would rather gain the 1 and have 8. Be aware, however, there are some exceptions. But in general, we're going to consider that the octet rule says that all of the atoms want to reach 8 valence electrons, so 8 is a happy number for atoms. Here's an example of the octet rule in action. On the one side, we have chlorine. Notice how chlorine has 7 valence electrons, so it will try to gain one more according to the octet rule that considers 8 a happy number. On the other side, we have sodium. Notice how sodium has the one valence electron. Now, if it gets rid of this electron, it will have a completely full valence shell because this one will disappear and it will have only this one over here. So what is going to happen is that sodium is going to give along this electron and it's going to go into chlorine, and then they're going to change, and both of them are going to become something completely different. Here is the moment where an ionic bond happens. This is a force of attraction between oppositely charged ions, and it occurs after gaining or losing electrons between metals and non-metals. Notice how we have chlorine and we have sodium. So what's going to happen is that sodium is going to give the one electron that it has. It's going to move on to chlorine, which is going to gain an electron. Because chlorine gains an electron, it becomes more negative. Because sodium loses an electron, it becomes more positive. And notice in here, now that sodium has lost that electron, he regains a full shell of valence electrons, so now he's very happy. This combination forms into a positive and a negative that are so attracted to each other that it cannot be separated. This compound is called a salt. A covalent bond is one that is formed between sharing electrons, and this happens between non-metals. They both transform into a compound that is called a molecule. Here we can see how the electrons are shared between them. Here we have 2 hydrogens and 1 oxygen. Notice that the oxygen is going to have 6 valence electrons, while the hydrogens are going to give each a valence electron, forming a compound that is known as water. Other types of covalent bonds can be formed between different nonmetals. Here we have water that shares 2 electrons. We have carbon dioxide, which shares 4 electrons. And we have nitrogen, which forms a triple bond sharing 6 electrons. So notice that in here I am sharing 2, here I'm sharing 4, and here I'm sharing 6. A metallic bond is a force of attraction between 2 or more metals. Many metal ions actually pass along many electrons, which will give them all the characteristics of a metal. Notice that the electrons are not going to stay in one place, but they're going to actually be moving and moving and moving around. Results of bonding then can be molecules, which are formed by nonmetals in covalent bonds. Other examples are metals, which can be formed between metallic bonds. Other examples can be salts, that are formed between a metal and a non-metal formed together by ionic bonds. And one example that only happens in molecules are the diatomic elements. They are 2 non-metals joined together by covalent bonds. So here we have 2 hydrogens, 2 of the same, 2 fluorines, 2 of the same, 2 oxygens, or 2 nitrogen. These are called diatomic elements because there are 2 elements of the same type. Now here's an extra credit question for you. Can you guess which one is a molecule, a compound, a salt, or a diatomic element? Write them in your notebook and show them next class for extra points. Have a great day!